average distance observations are from the mean. If I say the mean score of something is 80%, does that mean everyone got an 80%?
No.
No, there's variation in statistics, okay? And a standard deviation is a way to measure that variation. Let me give you an example. People who don't know anything about statistics may look at two classes. Class 1, the average score in the class is 72%. Class 2, it's also 72%. By statistics alone, does it matter which class you would be in, class 1 or class 2? By statistics alone, it does not. But if all of a sudden I tell you that the standard deviation for class 1 is 2%, and the standard deviation for class 2 is 10%, that changes things. I will get people who will call me. Now, this happened years ago. Ms. Opel, your class average was 60%. Are you going to allow a retake? Well, 60% isn't really telling them that much. If I would tell them the standard deviation, they'd say no. Or if I told them I had 6 people missing, and so part of that average was 6 zeros because they missed the test, then all of a sudden that's going to affect the average. The average is just one part of the picture in the whole statistical story, okay? What I like about statistics is it's telling a story behind some numbers. Now, our standard deviation gives us a bigger story. If we look at a standard deviation and we say it's the average distance observations are from the mean, that means on average, we know not everyone's going to get a 72. On average, they might be within 2% on either side, or even 4%. But it's a small spread. On average, people don't go too far off from 72%. Okay? But on class 2, the average standard deviation is 10%. So on average, people score within 10% of 72%. So they could get an 82% or a 62%. They can get above an 82% and they can get below a 62%. But the spread of the scores is further. It's more variable. So now if I would ask you, what class would you rather be in? Would you have an answer for me? Raise your hand with a number. Which one you'd rather be in, 2 or 1? Question, Gunnar.
It depends on which way they're sure, if it's 10% under, 10% over.
Okay, so what Gunnar just brought up, is it 10% over or 10% under? There is absolutely not a right answer here. Let me phrase it this way. If you are really good at math and you're always getting an A, what class are you going to want to be in for sure? 2. Tell me more. Yes?
There's a higher chance you'll get more than 72%.
Yeah, you can for sure. The average observations people are from the mean is bigger. It's more spread out. And if you're on the other side, on that 90 side, you want that average observation to be higher from 72%. But if you're a student that struggles in math, which class do you want to be in? Class number 1. Because class number 1, the average distance observations are from the mean is only 2%. So people really are scoring in the 70s. Okay? The average is 72. But overall, people are usually scoring in the 70s. Does that mean people are going to score above and below? Yes. But on average, it's in that range. Does that make sense to you what a standard deviation is, huh? A little bit, hopefully. So the lesson there is we always need a little bit more than just an average to tell the story behind some numbers. Okay, next. What a z-score is. And a z-score is another word for a standardized score. The exact interpretation of a z-score it is the exact standard deviation above or below the mean. So what I can do is I could give everyone a Z-score based on their ACT. My son has a really big what? I've talked about this to my first semester. Head. Okay? He's got a really big head. Okay? And his Z-score of a head is above a 3. That means he's over 3 standard deviations above the average for his head size for kids his age. Now, if you've seen my son, he looks totally normal. He's not like this Charlie Brown guy walking around, but he does have a larger head, okay? You can be below the mean. So a Z-score tells you exactly how many standard deviations you are above or below the mean. Now, you know when I was telling you how extreme an observation is? This is something to note. If you have a distribution that's normal, if you have a Z-score that is above or below plus or minus 2, that's considered extreme. My son's head size is considered extreme. It's the percentage of people that have it is very small. Okay?
Sierra seemed super weird looking at that when you said my son's head is extreme.
Well, what I mean by extreme is the chances of it occurring, of you running into someone with the same size head as him, is very small.
He's got a big head.
He's got a big head. Sierra's coming in at the wrong time. All right, let's go to the actual problems of Z-scores now. We only have 2 examples to do today, okay? You score 65 in a math test with a mean of 54 and a standard deviation of 3. You score an 80 at a history test with a mean of 75 and a standard deviation of 2. Which test did you do better when compared to the rest of the class? Yes.
SX is standard deviation.
Yes, good question. SX is standard deviation. Please write down this problem. I know we don't typically do a lot of word problems, but we only have 2 to do today. I'll pause the video while people write it down. All right, you can see on the right-hand side there, I put the Z-score formula. Make sure that you get that down. And remember, a Z-score is the same thing as a standardized score. You can use those interchangeably right now, okay? Right now you can do that. And a Z-score is we take our observation, we subtract the mean from it, hit enter, that's why I have the parentheses there, and then we divide by SX. And what did we establish that SX was? The standard deviation. Now, right now, if I told my mom, I said, Mom, I got a 65 on math and a 75 on history. Oh, I'm sorry, and an 80 on history. Strictly by the numbers alone, what does it seem like I did better on?
History.
History, right? But we don't know the big picture. It's kind of like I used to be a competitive figure skater, and I had a really bad competition. I got 4th place out of 6 skaters. And my mom told me when I go to school the next day, well, just tell me you got 4th place. They don't have to know how many people there are, right? So right now, by just looking at a 65 and an 80, we don't really know anything other than, oh, an 80 is better than 65. But what the mean and the standard deviation do is it gives us a bigger picture of what's going on. It tells the story, and that's what statistics is. It's telling the story behind numbers. So what we're going to do right now is we're going to find the Z-score for both courses. How am I going to set this up? I'm going to write math. And then what was it? History? I'm going to find the Z-score right now for both courses. So the Z-score for math. How did I score? What was my observation?
65.
Was it a 65 or a 60?
65.
Okay, 65. That's my observation, guys. That's right here. So I take my observation. I subtract the mean. 54. I divide by the standard deviation. So I take my calculator, and here's where people are making mistakes. If I type this in all at once, the calculator won't read it right. So you either use parentheses over the numerator, or you do the numerator first, hit enter, and then divide by the denominator. So when I take 65 minus 54, and I hit enter, I get 11, and then I divide by 3, and I get 3.67. With our z-scores, always round to the nearest hundredth. That's the second decimal place. This means I am at 3.67 standard deviations above the mean. What did I say is considered rare if it's normal data? 2. Plus or minus 2. So if I'm below -2 or above +2, it's considered unlikely to happen. How am I doing in math? I'm doing really well. I'm doing really well. Now let's look at history. History, I got an 80. So my observation is my 80. Minus my mean of a 75. Divided by 2. 80 minus 75 is 5. 5 divided by 2 is what? 2.5. Am I doing well in history?
You could be.
Well, if it's normal data, it's above 2. So yeah, I'm doing well. But which one am I doing better comparatively? And why? We need to be able to back it up then.
Because your z-score is
Your
higher.
score is higher than
Yeah, my z-score is higher. Very good. I have it's further from the mean. And in math and history and any schoolwork, we want to be above the mean. That's our goal. That's anyone's goal. Yes.
Will things like what it's out of, will that be on stuff like this later? Like if there's a test and depending on what it's out of?
That's a good question. And in fact, it doesn't matter what it's out of. As long as we have the mean and the standard deviation and our observation, we have the total picture. Now, granted, a 65 could be a D. Okay? But in statistics, we don't care about that it's a D. We care about where is our place comparatively. You think about it, we call it a measure of location. And then we make decisions based on that in statistics. So compared to everyone else, we're doing really well. And that's what we care about. Okay, last one here. There are 2 obstacle courses. Please write this down. Course A, the mean is 64 seconds with a standard deviation of 6.1 seconds. Course B, the mean is 75 seconds with a standard deviation of 8.7 seconds. So Mary's time is 59 seconds in course A, and Joel's time is 91 seconds in course B. Let's find their z-scores right now for both obstacle courses for Mary and Joel. Excuse me, not for both obstacle courses, for both people. So find a z-score for Mary in course A and a z-score for Joel in course B. I'm going to pause the video right now, and then I'm going to walk around, and if you have individual questions, let me know. But this is a time for you to try it and see how you do. All right, so you guys seem like you have it down when I quick walked around finding a z-score. Mary had a z-score of -0.82. Joel had a z-score of 1.84. Now my question is something Evan brought up. When you look at just the z-score, Joel's z-score is above the mean. So if I didn't have any story behind this, I would think Joel is more extreme. He's better. Right? But I have the story behind this, right? And the story behind this is the guy and the girl are doing what? A race. And in a race, do we want to be higher than the mean? No, we want to be lower than the mean. So who did better in their obstacle course?
Joel.
No, Mary.
Mary did better. Mary is negative 0.82 standard deviations below the mean. She's by no means a superstar, but she's doing better than average. Joel is not slow either, right? Because he's not above that 2. But he's also not, he's not slow, but he's not doing awesome either. Just wait, you're packing up. Let's quickly list some things where it's good to have a negative z-score. Racing.
Golf.
Golf. Anything else?
Tennis.
All right. I'm going to pause this. Yes, you have a worksheet to do tonight.